Okay, so last video we talked about, or we were calculating a value for R. R is your correlation coefficient. And what that is that's a measurement um, for how correlated or how much relation there is between two variables. So the closer you get to +1 or -1, there's more of a relation, basically more of a cause and effect. The closer it gets to 0, the less of a relation there is. The thing about it is at what point, like right now, it's this was one of the examples from the last video, 0.982. That's a strong positive relationship. Positive, we know obviously because it's greater than 0, but strong, yeah, strong. 0.98 is really close to 1. But is 0.92 strong? What about 0.86, 0.82? Like at what point is it considered strong? And that's a really good question. This next example that we looked at, 0.067, that's pretty easy to tell that it's fairly weak because it's really close to 0. But the question is, at what point does it change from weak to strong? Or at what point can we actually trust it? And I guess I want you to think of it this way. If you asked 10 people a question, okay, um, and 9 out of 10 of them answered it true, okay? Let's say, have you ever cheated on a test, okay? And you ask 10 people, and let's flip it, and let's say 9 out of 10 people said they have never ever cheated on a test. Would you believe that's the case? Would you believe that in general 90% of the population has never cheated on a test? Or would you think that, hey, maybe we just asked the right 10 people? Maybe it's more like 60% or 50% or something like that. So then the question is, well, what if we asked 100 people and 90 out of 100, still 90%, said they have never cheated on a test? You believe that number a little bit more than when it's only 9 out of 10. And take it a step further. If we asked 1,000 people, and out of 1,000 people, 900 people said they have never ever cheated on a test, you start to believe it a little bit more when there's a large number of people saying that, right? It feels a little bit more like it feels a little bit more valid. When only 9 out of 10 people say it, you think, well, if we would have asked 10 other people, it might have been 6 out of 10, right? So that's true too with this R value, this correlation coefficient. The value of R, whether or not it's strong, has an effect. The number of people that you have taken in your sample or that are in your population, that has an effect on whether it's strong or not. So if the value is like 0.85 and you've only, your sample was only like 5 people, that's not very strong because one person could really tip it one way or the other. If you've asked 5 million people, 0.85 is very strong. Okay, so make sure you understand that. If you have questions on that, please make sure that you ask me when we get back in class. But there's not just a hard value that says when R is this value, we can trust it and it's really strong. Or when this value, it's really weak. It all depends on the number of people in the sample or the population. Okay? So that in mind, we have this test that we use to figure out whether or not there's a correlation or not, whether there's a relationship between the two. And to do that, we have to state our hypothesis. Okay? So if you remembered seeing this value is rho. It's a Greek letter. It's called rho. That just stands for the correlation coefficient of a population. Okay, for everything that we're doing, this may as well be R. Okay? So think of this as R. So the null hypothesis means that there's no correlation between X and Y variables in the population. So we're basically saying, is the correlation coefficient 0? Okay? And then the opposite of that would be that R is not 0. So that would mean that there is a significant correlation. So we're talking two things. So let's just talk about your height compared to shoe size. The null hypothesis would say that there's no correlation between how tall you are and how big of a shoe you wear. And the alternative hypothesis would say that there is a correlation between how tall you are and the size of shoe you wear. Okay? Keep that in mind. The reason I don't necessarily like the way that they word all this, but it's the way that you're going to see it in the book and the way that you'll see it, you know, if you ever take stats in college. And so I think it's important that we state it that way. I'm going to state it a little bit different way to make it a little bit easier for you. So again, the null hypothesis means that there's no correlation. The alternative hypothesis means that there is a significant correlation. Okay? Okay. So here's this t-test. We use a t-test is what it's called to figure out whether or not the correlation that we find is significant. All right? So keep this in mind. So your t-value equals R, which is your correlation coefficient, times the square root of n, which is how many values are in your population or your sample, divided by 1 minus r squared. Okay. Degrees of freedom. This is just a term that they use. It kind of gives it almost like a buffer. Okay, think of it as a buffer. So here we go. This is how we use this. Test the significance of the correlation coefficient found in example 10-4. Okay, so we're going to look at that example. For alpha, use 0.05. I'll explain what that is in a second. And for R, we're using 0.982. All right. So the first thing we do is state the hypothesis. Okay. Second thing we do is find the critical value. The way that you find this critical value, I'm going to go back. Step 1. Okay. If you're looking at example 10-4 in your book, that example dealt with the car rental companies. So this was the one, it was a little bit earlier, it was on the last video. And what they were wondering is does the number of cars that a company rents have an effect on their income, how much money they make? Okay. So our null hypothesis would be there is no significant correlation between the number of cars rented and the annual income of a company. So again, there is no significant correlation between the number of cars rented and the annual income of that company. Your alternative hypothesis would be there is a significant correlation between the number of cars rented and the annual income of a company. So we're basically going to find out which one of these is true. Is there a correlation or is there not? Okay. So we're going to use alpha at 0.05. Think of that as a percent, 5%, okay? And there's 6 minus 2 degrees of freedom. So that's just that buffer. What we do is we go to the back of the book. We need to know that degrees of freedom. So we take 6 minus 2, we get 4. We go to table F in the back of the book, which is on page 784. And the way that we're looking at this, there are different confidence intervals. And all a confidence interval is like how confident are you in this? Are you 80% confident, 90% confident, 95, 98, 99? How confident are you in this result? What we normally use in this book is we use a 95% confidence interval. Okay, so that's That's what that 0.05 means, is it's 5% away from being 100% confident. So we go to table F, and we look at our degrees of freedom. On the left-hand side, we're looking at 4. We go over to our column where it says 2 tails is 0.05, or the 95%, and we have 2.776. Okay, so 2.776, we use a plus and a minus. Okay, so keep that 2.776 in mind. Then we calculate our t-value. Okay, and when we calculate that, we're going to end up rejecting the null hypothesis. Here's why. When we plug those numbers in, we get a value of 10.4. If you do this, you use 0.982 right here. Okay, use 6 minus 2 divided by 1 minus 0.982 squared. And we get a value of 10.4. Because 10.4 is above this, okay, because it's above this, we're going to reject the null hypothesis, meaning we're rejecting the fact that there is no correlation. Okay, so we're rejecting that null hypothesis, that there was no correlation. So what we actually mean is that there is a correlation. So I'm going to think about it this way. If we end up on this side of that boundary or this side of the boundary, that means it's strong enough to basically accept our R value. When it falls in here, it's saying that it could have happened by chance. Okay? Again, I think there are going to be some questions on this, so make sure you write them down and we can answer them on when we get back to class. So to summarize our results, there is a significant relationship between the number of cars a rental agency owns, sorry, I said rented, and its annual income. Okay? We do this again. We're doing this now for, oh, sorry, we don't want to do this one. Let's skip past this one. Now, when that happens, you think of what could be the reason. Like if we reject that, so I mean if it's significant enough, what are the reasons? Well, the one reason is obviously that the first one thing causes another thing, direct cause and effect. Okay, so that the number of cars that a car company owns and the annual causes the annual income to go up. So as X goes up, so does Y. The other thing is that it could have been a reverse effect. Okay, that actually instead Y causes X. So let's say this. Let's say we were doing an experiment and we wanted to find out, does the number of energy drinks that you drink in a day, does that cause you to stay up later? Okay, does that cause you to stay up later? You may find out that it's actually a reverse effect. It's not that the energy drinks cause you to stay up later. It's the fact that people that stay up later they don't get as much sleep and they need kind of a boost. And so they drink more energy drinks. So it's actually a reverse cause and effect. It's not that the energy drinks cause you to stay up later. It's the fact that you're staying up later, which causes you to need that little boost. And so you drink more energy drinks. So that would be a reverse cause and effect. There also may be a third variable that causes it. So something that we're not looking at, does the amount of sleep you have create an increase in your GPA? It might not be the sleep at all. It may be the fact that you study harder or, things of that nature. There may be a very complex interrelationships. This is one of those. Earlier on, I said we weren't going to look at the multiple relationships. That's what this would be. Or it's possible that it's just coincidence. Okay? It could be possible that it's just pure coincidence. It's not that X causes Y, it's just by pure coincidence. Okay, So real quick, I'll go through some of these. You don't have to necessarily write all these down, but you can if you want an example. So a reverse cause and effect relationship, that could be where water causes plant to grow, poison causes death, heat causes ice to melt. Oops. Sorry, that should not say reverse cause and effect. That first one should say direct cause and effect. Sorry, typo. That should be direct cause and effect. More water, more the plant grows. More poison, something has, the more likely it is to die. As the heat goes up, the ice starts to melt. So that's a direct cause and effect. A reverse would be if a researcher believes that coffee consumption causes nervousness, but instead they find out that nervous people may drink more coffee to kind of calm their nerves. So that's another example. That third variable, if a statistician correlated the number of deaths due to drowning and the number of cans of soft drinks consumed daily during the summer, he or she would probably find that more soft drinks that are drank, there are more deaths. Okay, they may find that. That doesn't necessarily mean though that soft drinks causes death in the summer. Okay, it may be that you drink more soft drinks when it's hot, and when it's hot, there's a bigger chance that you die due to heat stroke. So it's not that they're related to each other. A researcher may also find a significant, so this could be complex, significant relationship between students' high school grades and college grades, but there probably are many other variables involved, such as their IQ, how much they study, their parents, their motivation, some of the instructors they have. So that would be something that it's not usually like a direct cause and effect. And it may be coincidental. Researcher may find a significant relationship between the increase in the number of people who are exercising and the increase in the number of people who are committing crimes. Do you think that by exercising more people are committing crimes? No. It just happens that it's pure coincidence. So those are some things that could happen. If you find that there's a significant relationship or a significant correlation between two variables, there are a number of different reasons for that. And that's stuff I want you to talk about in your paper is like, what do you think could cause that? Is it a direct cause and effect? Is it pure coincidence? And so forth. So that's it for this video. Again, write down your questions, and we will see you tomorrow.